today's class, we will learn about problems on half-range Fourier series. The problem is, show that the sine half-range series for the function f of x is equal to lx minus x square in x greater than 0 less than L is 8L square upon pi cube summation 0 to infinity 1 upon 2n plus 1 whole cube into sine of 2n plus 1 whole divided by L.
Hello students, in today's class we'll see the problems on half-range Fourier series. The problem is, show that the sine half-range series for the function f of x is equal to lx minus x square in x greater than 0 less than L is 8L square upon pi cube into summation n from 0 to infinity 1 upon 2n plus 1 raised to 3 sine of 2n plus 1 upon L into pi x. So this is a given question and this is the required solution we need to prove here. So we'll see the solution now. The sine half range Fourier series is a half-range Fourier series in, because this is in terms of 0 to L, means arbitrary, that is 0 to L is given by f of x is equal to summation n from 1 to infinity bn into sine of n pi x upon L is the sine half range Fourier series. I will give equation number 1, where bn is equal to 2 upon L 0 to L f of x into sine of n pi x upon L into dx. So this is a Bn, that is Fourier coefficient. Now we'll find the value of Bn and we'll apply the equation number 1 and we'll see that whether we'll get this required result or not. So we'll check now. So therefore, we'll use our f of x. So here f of x according to the question is, it is lx minus x square in the interval 0 comma L. So we'll use this and we'll find the Bn value. So therefore Bn is equal to 2 upon L value is L itself, 0 to L, f of x value is lx minus x square into sine of n pi x upon L into dx. So this is the value of our f of x we have applied. Now so this will treat as u and this will treat as v, that is uv, integration of uv by applying Bernoulli's rule of integration, that is Bn is equal to 2 upon L as it is, bracket. So we'll keep u as it is, that is lx minus x square will keep as it is. Integration of sine is out here, minus cos of n pi x upon L whole divided by n pi upon L. Formula minus differentiation of Lx minus x square is L minus 2x, then minus 1 upon n pi upon L will become out here minus L upon n pi into integration of cos n pi x upon L will become out here sine of n pi x upon L. Next, differentiation of is possible here, so I will continue. Plus differentiation of L minus 2x is 0 minus 2, so minus L upon n pi, and so here I also will get n pi upon L. So this n pi upon L will become out here minus L square upon n square pi square into different integration of sine n pi x upon L will become out here. It is minus cos of n pi x upon L divided by n pi upon L. So next differentiation is 0, so we'll stop it and close with the limit 0 to L. Next Bn we'll see here, so 2 upon L. So here if you apply in this middle term, that is for sine, if you apply x by L, so it will become sine L pi and 0. So both in for upper and lower limit it will vanish, it will become 0. So remaining part I will collect here. It will be Lx minus x square, this minus sign I will take before the bracket, into cos of n pi x upon L into this n pi upon L, I will write L upon n pi. This second term vanish because if you replace x by L, it will become sine n pi, because L cancel, sine n pi is what here? 0. If you apply lower limit, sine of 0 is 0, so that's why the middle term I have made as 0, because it will turn to 0. Then here next 0 minus 2 will be what here? Minus 2. This minus and this minus will become plus, plus into minus is again minus. So L square into n square pi square into this L into n pi, it will become out here L cube divided by n cube pi cube into cos of n pi x upon L, limit from 0 to L. So we'll apply upper and lower limit in these terms and we'll see what happens. So in the previous step I had taken minus sign out and I have rearranged. Now we'll apply upper and lower limit here. So Bn is equal to minus 2 upon L bracket. So if you apply upper limit as L in the first term, that is if you apply x is equal to L, so L into x will become L, L into L is L square, and here we have x square, so L square minus L square is 0, 0 into this entire thing will be out here 0, so 0 plus the second term, if you replace x by L, it will become out here 2L cube divided by n cube pi cube into cos of, if you replace x by L, L cancels, will left with what here? Cos of n pi. So this is for upper limit. Minus, we'll apply the lower limit. If you replace x is equal to 0, so here it will become out here L into 0 is 0 minus 0 square, that is 0 minus 0 is again what will get? 0, 0 into this entire thing will be what here again 0, plus second term, if you replace x is equal to 0, so what happen here? Cos of 0 is 1, 1 into this entire thing, that is 2L cube divided by n cube pi cube. So we have applied upper and lower limit here. Now we'll think of final simplification, that is minus 2 upon L. So what happens here? 2l cube divided by n cube pi cube cos of n pi. Cos of n pi is what here? Minus 1 raised to n minus, this minus into plus is minus. Here we have left with 2l cube upon n cube pi cube. So among this, what is common we'll take. So 2 is common and L cube upon n cube pi cube is common. So therefore Bn is equal to minus 2 upon L into 2 upon L cube divided by n cube pi cube is common. So what left inside here? Minus 1 raised to n minus 1. So on simplification, Bn is equal to minus 2 into 2 is 4 minus 4. So this 1l and among this 1l cancel, so L square divided by n cube pi cube into minus 1 raised to n minus 1. So this is, I can say that, a value of our Bn, or we can elaborate and we'll write it as Bn is this minus sign will apply to this bracket, so this will become minus sign, this will become plus, or I can say that, or 4l square divided by n cube pi cube will become what here. So if you apply this minus sign to this bracket, it will become 1 minus of minus 1 raised to n. So either of the result we can use for the equation number 1, that is our Fourier series. Therefore the equation 1 becomes f of x is equal to summation n from 1 to infinity Bn value, that is 4l square divided by n cube pi cube into 1 minus minus 1 raised to n into sine of n pi x upon L. So this is our equation number 1. We have applied the value of what here, f of x, or I can take the constant term outside. So therefore f of x is equal to, so among these constant terms are, so 4 L square I can take and pi cube. So 4L square upon pi cube is a constant. So summation n from 1 to infinity. So what left inside this bracket, that is minus 1 raised to so 1 minus minus 1 raised to n divided by n cube is left inside into sine of n pi x upon L. Or else I'll rewrite this one. So f of x is equal to 4l square divided by pi cube summation n from 1 to infinity 1 minus minus 1 raised to n divided by n cube into sine of n pi x upon L. So this is a required Fourier series. But this required Fourier series is not fulfilling our required solution which is asked in the given question. So we'll see, I think so we need to apply the value of n, that is what happens we'll see, and we'll think that whether it will fulfill the result. So we'll check with the values of n will take 1 2 3 here in this entire result. So whether we'll get the results or no, we'll check now. Okay, so if you take n is equal to 1 2 3 so on, we'll check. So first I want to work out this 1 minus of minus 1 raised to n. So what happens we'll see. So 1 minus of minus 1 raised to n is nothing but I can say that it will be, if you put n is equal to 1, just check here, 1 minus, if n is even in the sense what here, the value 2 4 6, it will become what here, plus sign. and if you apply n is equal to 1 odd numbers, so I can say that if it will be even, if it is even number plus sign, so 1 minus 1 will become what here 0 if n is what here even, and 1 minus of minus 1 which is nothing but 2 if n is odd. So this is a simplification, you can check and we'll see. So I can say that if you apply here n is equal to in the entire stream, this result, if you put n is equal to even numbers, that is 2 4 6 8 so on, so the complete entire result will become out here 0. So what we'll do here, we'll put only the odd numbers. So I can say that when n is equal to 1 3 5 7 so on, we'll get the result as, if you apply there, that is f of x is equal to 4l square divided by pi cube. So what happened here, summation n is nothing but we are putting 1 3 5 so on to infinity. So the above, only the above term, means this above term is turning to what here 2, so I am writing that, that is 2 divided by n cube. I have not applied purely value of this one, so 2 divided by n cube into sine of n pi x upon l. I have not applied, just applied the value for what here 1 minus minus of minus 1 raised to n I have applied. Now we'll go for the final conclusion. So here this 2 you take outside, so 2 into 4 is 8, l square divided by pi cube, summation n from 1 3 5 so on to a infinity, it will be 1 upon n cube into sine of n pi x upon l. So here what happens, but we are considering what here n value as 1 3 5 7 so on are what here odd numbers, which represent what here, represented in general, because the result is general, in general as what here odd numbers always represent in general as what here 2n plus 1, where 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 when is become n is what here 0 1 2 3 so on. If n is equal to 0 1 2 3 so on, in that what here 1 3 5 7 so are considered as what here odd, which are odd numbers and represent 2n minus 1. Therefore the above expression f of x is equal to 8l square upon pi cube. So what happens here, summation n from 0 to infinity, so here n value will turn to what here odd number is what here 2n plus 1, this whole cube as it is, into wherever n is there will replace it. So sine of, here also we have n will become what here 2n plus 1 divided by this l as it is into n into nx, sorry, into uh, x into pi or pi into x I can say. So therefore the required result I will rewrite. So fx is equal to 8l square upon pi cube summation n from 0 to infinity 1 upon 2n plus 1 raised to cube into sine of 2n plus 1 divided by l into pi x. So this is a required sine half range Fourier series.